Hello everyone, welcome to Practical GCP. So today we're going to cover a pretty hot topic that everyone's been talking about for a while, but I want to do it in a way that is more practical and useful, at least from my point of view. So the AI has a lot of hype recently, especially in the field of LLMs. But today I actually spend quite a bit of time looking into this, and I think this is, at least to me, is a very useful application of how you can actually leverage Langchain and BigQuery Vector search in this specific example. It does go wider scope than this at the end, with more opportunities, but I'll cover that later on. So, the content for today, I'll cover what is Langchain specifically, to start with, and some of the technical terms that I think is useful, to explain, and that used throughout this presentation. The use case, I had in mind, which I've also implemented. I want to explain why am I doing this, and with the detailed architectures of what actually involved to build it. As usual, I'll do a demo, a code walkthrough, and also talk about opportunities and the pros and cons of using Langchain with BigQuery Vector search. Okay, what is Langchain? So, Langchain is a framework designed to facilitate the integration of language models into various applications, offering tools for easy implementation. So think it as a way that you can glue a lot of things together, right, to enable you to kind of populating data into, such as today in a vector database, integrating with different kind of APIs, and also perform search and then using the LLMs to present the results into users. So it's kind of a way you can chain a lot of things together, but without actually going through all of that complex integrations yourself. And specifically, you can swap things around, right? It's not actually limited to one single cloud or technology. It is actually allows you to decide as a user how you want to implement your end-to-end. So the few technical terms I think is worth mentioning to cover in this presentation. So first of all, LLMs. This is something I think all of you know. Large language models such as ChatGPT, Gemini, which has been released in GA recently. So those are basically, just in case you don't know, is a way that you can really kind of using language models, like you talk to it and it talk back to you like humans with vast amount of knowledge and information, and to present in an extremely elegant way. So embeddings. So in terms of embeddings, this is not probably, especially if you're from the engineering background, you may not have heard about this term. So it is basically a numerical representation of text, words, or other data. You can transform these into vectors in a high-dimensional space to capture their semantics, relationships, and all this stuff. This is very, very useful for machine learning models, especially in the sense of vector search. So vector search is a technique that retrieves the most relevant terms, like a distance comparison, finding something that's most close to what you're searching for, by comparing the vector embeddings in a highly dimensional space to find the closest matches. So those are the three key things I have been using in the examples here that I'm presenting to you to build this end-to-end application. So hopefully this is something you find useful. So I've got a use case here. So something has been bothering me for a long time is, let's say in a large organization, you've got a lot of this knowledge base, ticketing systems. You have, let's say you have Confluence, where that's your knowledge base are, but it's all over the place, right? So you started creating one section followed by another section. Some of these are out of date, but you always know as yourself, as a team, where they are, but other people using those things may not know. And it's extremely difficult to find those things. The same thing with Jira. You have a lot of tickets created all over the place, but when people start asking you, can you give me I want to know what's been done and what people are talking about. There's issues in there. There isn't really a easy way to find things in Jira either, because there's lots of board, lots of teams. And also Slack messages is one of these things, especially in public channels, there's lots of topic being discussed, talked about, but there isn't really a way to, really understand what other issues that people are referring to and talking about in different sections, in different channels. So, and how do you get this data together in a way that you can make it useful? And the last thing, but not least, are the code base, right? So you have a lot of code base that sits in version control in Git. But, how do you find a way to, let's say, maybe find if there's bugs in there, if there's security issues in there, and then there's other tools built in there, but what if you want to do some of this yourself, and then specifically in certain projects you're interested in? This is where, I've got this idea of, okay, you have a bunch of users within the organization. They want to ask some questions, right? And then you have a web app in some sort of form. Then you want to do some search based on this information you've collected. And it has to be accurate, right? So I'll give you an example why the accuracy is really, really key here. Let's say, these, Slack conferences, they're all implementing their own, search, right? So maybe vector search, maybe, you can just ask a question in natural text. But the problem is, without some specific context and curating your data, it's always answering question in this way that is not very useful, right? It gives you too much information that, not relevant to what you're searching for. But imagine this is where it connects to the world of data engineering, right? Then you actually get the information that is correct, right? Model it in a specific way and then put that data in some sort of form in the database. And then the only thing that you serve to the users are very specific to that context. That's where you can actually make something useful rather than just following the hype. This is what it looks like, in the architecture that I've implemented here. So try not to look at the whole thing. I'll walk you through it. So start from the top one, right? This is the bit that populating the database in the previous page, right? So Langchain has given you quite a lot of wrapper classes and libraries that you can actually, in this case, for example, I've just keep things simple. I want to crop some content, right? So it's like there's lots of web pages. It's got information. I want to crop some data, right? And then this is where the crawler comes in. I'll crawl some web content and I'll extract useful information such as, the metadata size, such as the length. I can give you a context. Let's say later on you can find an example. So I've used it's actually in the tutorial, the Longsmith, which is a paid service, that help you to look at logging and monitoring in Langchain. But you're probably interested in how much it costs, what's the pricing model, all of this stuff, right? That's all in a single page. Then you can actually extract information about what the context that is, how much your text, like how long is your text. So these can be useful later on in the search. And then you can generate embeddings. So as we mentioned earlier, you can generate embeddings, basically turning the chunk of content and text you've created in this particular case and use, the embedding API. So just keep in mind that to generate embeddings, it will require a well-trained language models to be able to do that, to give you those, array of numbers, right? So, in this case, I'm using the Vertex AI embedding API to actually give me the embeddings. I pass it the text, it gives me an embedding, and then I store it with BigQuery. It's basically rows with vectors, right? Those embeddings we convert it into vectors, basically those numbers, in the representation in a string column, right? I'll show you later on what it looks like. And then that goes into BigQuery. Right. This is the ingesting and processing the data part. This is really important. And it's just data engineering, right? You get some data, you shape it and format it, extract useful information, categorize it, then you put it into the BigQuery, database. At this point, there's nothing to do with the vector search just yet, right? It's just you create the embeddings based on the text you've gathering from the crawled content and you store it, right? That's the first part. Then later on, we'll talk about retrievals. Right now, look at the serving process. So looking from the right-hand side, I'm a user, right? I'm asking something, look, tell me what is big frame. So this is actually one of the examples I'm using the cross content in today as well. I probably have a web app, and then it looks into, there's some sort of natural language, which is basically this tell me what is big frame state. But it also has a context in this particular case, right? You see in the demo that the context is actually really key because it narrows down the scope of the question. So it doesn't actually go out of the context and start talking all of this random stuff. And then this is the most important part. It will use the vectors, it will use the embedding API to basically convert your tell me what big frames is into a bunch of vectors, right? And then because you also have the context, you can use the context to filter, plus, this will reduce the amount of data you search, right, in the vector search. And then you do the vector search. Basically is comparing the similarity of what you're providing and what you've got in the database. This will then return the relevant content based on the content you provided. Then, this is the most interesting part, but it's actually the very little bit. So a lot of people thinking LLM is everything, right? It's everything kind of this whole, most important thing is about this LLM itself. But not really, right? The top, all of this stuff, right? I was talking about in the top. There's nothing to do with this, converting to human readable language, asking for questions, providing answers. Not yet, right? But this part is also important, but it's just a very thin layer of it. In this case, I'm using the ChatGPT API to, basically feed all of this relevant content, right, I've provided into the ChatGPT API. So then you can turn the content I've got into a much better way to represent the answer back to the users, such as BigQuery is easy to learn, completely serverless distributed compute orchestration framework for batch processing, right? So that's something that this will complete the whole end-to-end implementation, right? So to summarize, you've got the ingestion and processing part, just the data engineering work, and get the data crawled or collected, and put it into, get the embeddings generated and converted into vectors, and then store it in the BigQuery database. And then as a user, you search for the web content in natural language, you convert those into vectors again, and then providing a context, and it can give you much tailored information with much relevant content. Then you'll return these, pass into the LLMs, then it'll give you a much more meaningful answer, right? Right. So now let's look at the demo. This is a screenshot of what the super simple web ad took me like 10 minutes to create. But it does give you an idea what you can do, right? And then if you put this app behind IAP inside the organization, then you can actually use it, right, to serve the content to the people actually looking for answers within your organization. But let's have a look at the app itself. Right. There you go. So, I'll give you some background of what data this thing has, right? In the vector database in this case, it's just a BigQuery table. I've done 4 ingestions and processing, 4 different, web pages, right? Crawling the data from these 4. One is from the Langchain tutorial, which has the longsmith pricing page. And I've also crawled 3 other pages, which are basically the practical GCP blog content I've written. One is Cloud Workstations, one is BigFrames, one is Dataplex, right? So let's have a look at how powerful this thing is. But first of all, right, I want to go to the longsmith page so you can have a look at yourself what is in the content. And then you very quickly realize why this is useful to you and your organization. You've got pricing, right? And it's got lots of information in this kind of tabular where you've got developer plan, plus plan, enterprise plan, and all this stuff. You've got a comparison, you've got question answers, what are all these things, right? So now, what the ingestion process does is you crawl the whole content and break it into chunks of text and then store them as individual rows in BigQuery. Why is that important? Because if you don't do that, you could end up crossing the whole page, and that could be a lot of information. And a lot of that information, and maybe only part of that is what you need. Maybe you just need pricing in here, right? So now let's have a look. Let's say I want to know how much actually cost me for, let's say the Plus license, right? What I can say is, how much does it cost me on the Plus license? Like, I'm asking something very specific, right? Let's say per month. Yeah? Look, so it's telling me it costs me 39 per user per month on the Plus package. Is that correct? 39 per user. Yeah, that's actually quite good. But how about if I ask for something, okay, there's 3 traces, right? Let's say I'm interested in a trace. How much free trace I get on the plus package with longsmith. There you go, 8,000 you get in there, right? But then you can also ask for things something like, how much does it cost me on the plus license per year for 10 users, maybe, right? I've not tried this before. Let's see if this works. So you see, this is quite useful, right? So, the 10 users would cost you 390 per month, which is correct. And 300 times 12 is 480. This looks correct as well, right? So this is where it's very interesting, because you've provided the base information that you wanted. The information you're providing actually knows, right? Then you can combine with the power of large language models to do a little bit of math in here, and then to do a bit of calculation for you based on, what you want to know, right? This is how these two gets combined together. With accuracy is very important. However, this is what's interesting. Let's say if I want to ask something about, what does big frame do, right? If you ask this on the ChatGPT, it will actually give you an answer, right? What does big frames do? But now I've given it context of longsmith pricing. Let's see what this one does. And you see, it tells you it cannot answer questions about big frame because it's not part of the context. Because this is what's very useful. First of all, when you select the context, it will not feed any information about other random stuff such as big frames in this particular case. All it's focusing on is longsmith pricing, right? And then if you ask anything outside of this context, it won't actually give you anything. However, if I switch to big frames, and I want to ask something about what is big frames, right? It's the same question. What is big frames? And then you can see now it works, right? Now it's telling you, it's easy to learn, complete service, distributed computing orchestration framework for batch processing. Now, so this is again providing the context based on the information from the vector search you provided behind the scenes. You can actually, so this is the big frame page, right? But you can actually look at all of this other, because it's crawled the whole page, you can say, what are the pros and cons using big frames? Then you should be able to go and crawl the content, the search for the content that is relevant to the pros and cons in this particular case, right? And then now you would see the pros. You can use remote functions and some servers, blah, blah, blah. And then the cons, it cannot configure dynamically, with the created remote functions, which is exactly what I provided in there. And it doesn't have an easy way to maintain dynamically created remote functions, ingress routes to public. That's all the things I've actually put in there. But it's put in a way that is very easy for humans to understand, which is why it's super powerful when you combine this together, right? So this is basically the demo. It's a very simple way, like a website, but keep in mind that, if you have very good, high quality data that you feed into, to the backend, and you actually supplied it within a specific context that is useful for the users to search, then you'll provide much relevant and higher quality content, right? So now I'm going to go into the code base, because in order to understand how this works, I think it's important to run through how the ingestion part is done, and then how the data gets kind of stored, converted to the embeddings and stored in the as vectors, but also how to retrieve it, right? So not a lot of code in here, but it does have a little bit complexity in here, so I'll walk you through it. So first of all, let's look at the LLM part, right? I'm not sure why I call it LLM, but this is the kind of the entry point for doing the ingest and doing the search, right? Let's start with the ingest. So the ingest, there are 4 different things I've actually ingested as vectors. So we've created some helper functions. In this case, I've got a context. You can see this is basically what's correlated to the drop down menus, and then you have a URL. where you crawl your content, right? This you have from the Langchain, longsmith pricing all the way to big frames, dataplex, workstations, wherever. You can replace this with whatever you like. Obviously, I didn't deal with authentication, authorization. That's something that needs to be implemented on top. And then what this does is, in this case, it's got a web crawler. I'm not going to talk too much about it, but it got this thing. One thing I don't know about it is like I need to look into more on how to accurately split the data. But obviously, if you have the data, already ingested in a much more meaningful way, then you can split it in much better ways than, it's just trying to, because this is from the crawled content, right? It's probably the worst possible, the ways you can do this. But if you actually have data can be exported, let's say from Confluence, the page can be exported in a more meaningful way as like I don't know, CSVs, JSON lines, and those can be stored in a much better way than maybe via sections rather than splitting this way. But it's just a way to reduce the size of your content. So then when you're storing these as vectors and doing the search, it doesn't return everything. Therefore, reducing your bill, how much data you pass to the LLMs when you actually want to translate to the users, and also improves the performance of the search, right? And then what you're basically doing here is similar as what I just explained in the architecture. You get some metadata out of this. In this case, you provide the content, you check the length of the page, and then you create the vectors. So this leads us into the BigQuery Vectors module. So what this does is I've created some helper classes. One is properties, one is the factor class to basically create the vector. So literally in this case is the BigQuery one, right? So a few kind of lines of boilerplate code, but all this does is using this BigQuery Vector search. Right? This is a Langchain provided class that allows you to do a number of things. It uses a project, a dataset, and table combination to create a default table for you based on a certain schema for you to store your vectors, right? And then I'll show you what it looks like in a bit. And then you supply the embedding you want to use, and this is basically in this case, I'm using the Vertex AI embeddings because I found it better quality than the OpenAI embedding. But the beauty of this is you can literally just swap this line, 3 lines but 1 line, whatever, to actually use the OpenAI embedding if you find that one is actually working better than the Vertex AI ones, right? That's just 1 line of code you have to swap to achieve using a very different endpoint to convert your text into embeddings. And then you choose your distance strategy. This is how it actually gonna, convert doing the search on, because this store is used for the search primarily for the search actually, but also you use this, it has a helper function to help you to convert and store the vectors into BigQuery, right? But then that's it. This is the store, right? And then if you look at the code here, all it does is creating the data set, truncate if you want it, because I'm actually doing a demo in this case. It's like a data engineering pipeline in reality you probably want to use to do this sort of stuff. And then you just add your text. That is your metadata and the bunch of text you've got that you want to store in the database. So you might be wondering, what the heck is this local class? This is the bit of problem I had when, I'll show you what it is, right? I've got a issue when I'm using the original one, which is the BigQuery Vector search. And because if you look at this line specifically, because, I'm explaining this because you might run into the same issue as well. What it's assuming is, because the thing is, this thing is stored in a JSON data type in BigQuery. So it's assuming when it's actually retrieving the data, it will give you a string, but that's not true. It will actually give you a dictionary. So then this will throw an exception, right? So all I'm doing is just a hack for now to catch the error, because if it's a dictionary, this is exactly what it's doing. So it's the same thing. And this might help you to get around the problem. But it really raises a question like, also this code gets duplicated a few times in this class as well. So it's like, did this even work? Because this schema is created by this Langchain Vertex AI, the vector search class, right? So I didn't actually change anything. But how comes it works one way, which actually, putting the data in, but it doesn't work on the way out? So I'm just a bit surprised. And then, in order to fix this, I had to look through all of the source codes to see, which line is actually causing the problem. That's how I found it. But just explain it, because this is why I had to go through this, and a subclass in this thing, it looks a bit crazy. But that's what I had to do to make it work. Okay. So, let's go back. So I want to show you what the data looks like as well, right? So this is a good opportunity to show you the actual schema of the table. You can see this is a project ID, data set ID, table ID, and it's created the schema with, the document ID, the metadata, content, and text embedding. And that problem I was referring to is exactly, to do with this metadata, and it doesn't, when it comes back, it doesn't work because it's a JSON data type, not a string data type, right? That's probably where the bug came from. But if you look at the preview, this is what you would be expecting, right? If you look at the, let's say as an example, this is just a one line. This is the header, right? When it did the split of the text, this is the longsmith page. It's got a context in here. It's got a length in there. Then it got loads of numbers. This is basically an array of floats, and then representation of the embeddings. But if you look at this one, which I've only included the metadata and content, and that's what I basically put into the database with those 4 ingestion commands. You can see you've got the context, the length, but also in the content, you have the content's broken into chunks, right? So even for the big frame ones, you've got 1, 2, 3, 4 of them, right? Split into different sections, which when you're doing a vector search, you might not necessarily need all of it, right? So if you look at the search, which, in the demo I've just done, you can see this is the query run. If I open it up to, I think I can do it here. Open in the query editor, you can see this is the actual, query it run. So you can see it's actually using context big frames in the filter. So this makes sure it doesn't include anything that is outside of the metadata, context, right? So then it doesn't do the vector search on all of this useless content. And then, all it does is to do a vector search based on the data you've got left, based on the distance type, right? And then you're returning the top 4 results. So you can change all of this, but this is basically just what it does behind the scenes on BigQuery in the vector search. There's nothing complicated, from a user like you and me point of view. But yeah, so that's what you actually get in a database, and that's what it actually returns. So if I actually run this, I can see in this case, it's returned quite a lot. I don't know how many rows this is. What does it say? Drop information, it returned results 1, 2. It's quite hard to see, but never mind. But you can see this is return a vector, and it's got the things that match into what you have got, right? This is things that what you have got with what you have in the database. Okay, back to the code. Now I want to talk about the search. So in the LLM module, the search is actually a combination of a chain. So in this case, you see what's happening here is you need a prompt, right? A prompt template. And this is how it managed to restrict the context to exactly what you're asking. So first of all, you've got a restriction saying answer the following question based on only the provided context. You've got a prompt based on this template with the context, which is basically what's returned from the search of the vector, from the vector database. And then you supply a question with a templated input, right? That's how this prompt is put together. And then you create a chain of your document. And what this does is you can see there's one thing called LLM. This is using the ChatGPT Open AI, right? Again, like I said earlier, you can easily swap this out with the Gemini with one line of code, right? And then it will use a different LLM engine instead behind the scenes, which is, again, the beauty of this framework. And then you put this and you chain the LLM and the prompt together. But you need data, right? This is what's done by the retriever. The retriever is basically something, you can see this as a class, right? That implements certain functionalities to return a bunch of documents. So each row that you return from, in this case, the BigQuery database, is a document. This is expecting a list of those things after the search. So it doesn't have to be vector, it can be whatever you like, right? But it just has to return a list of documents in this particular case. And if you look at the BigQuery retriever class, the way this works is you basically subclassing an abstract class called the base retriever. It's like implementing an interface. Then you do a bunch of things to say what you want to do to override. You override the get relevant documents method, and then you provide what you want to do, and then this has to return a bunch of documents, right? In this case, document is a class that built into Langchain, and then it will connect to the rest of the chain. But again, I have a problem here because I didn't know how to do this. There's nothing built in or documentation explaining how to create a retriever. So, and then one thing I don't understand is why do I have to kind of subclass? Isn't there a way, you can provide me a way to ingest, some sort of functions or implementation as like composition instead of inheritance, which is quite, for example, things like this, right? How do you know you're going to have to do this to make it work, right? Or these, it's just quite difficult to understand exactly what you need to do in here to create your own retriever because there is no built-in one. So I guess I would prefer this some sort of composition over inheritance mechanism that I can basically do my own implementation, implement the interface, and then pass it in, it will just work, right? Or just give it a function, whatever. But this is quite, really difficult for the user to figure out how to use this. And it's quite, it's not exactly very clean, right? If you look at this stuff, what the heck is this, right? So I think that's just a bit of a difficulty I had. Took me quite a long time to look through the source code, to understand, okay, this is what I have to do to create my own retriever, to, bundle it into the chain. But the rest is actually quite straightforward. If you look at the rest, you just need to bundle the retriever now with the document chain, and this will now feed all of the information you retrieve from the vector database into the document chain via the LLM. Then, based on the input you've given it, now this is giving you an output and an answer back to the user. And that's basically how you're seeing this stuff, right? So that's pretty much the whole code base. There's nothing else. The app is just like 26 lines. There's nothing complicated in here. This is just the app with an index HTML template. Yeah, that's pretty much the whole thing. Okay, back to the slide. I want to talk about a few opportunities in here because this is something got me really interested because I'm always a practical guy and wants to see, okay, what can you do with this sort of thing, right? And with very high accuracy, this is something I care a lot because I don't want to see things that is completely irrelevant and people don't want to use it. I want to have really well curated information through data engineering, feeding that data into the backend database, and then to create a relatively high quality retrieval mechanism based on the context. So then I can provide value to the users or the customers, whatever, right? So here I've listed 3 things that I've seen, in my view, I think is quite useful. And the color represents risk. Green is almost zero, no risk or very minimum risk. Yellow is, you can still get it wrong, but it's not the end of the world. Red is you need to be really careful with this stuff, right? I'll explain one by one. I think the knowledge-based stuff, as I mentioned, in Confluence or in Jira, you can actually, you can see the LLM buttons people create and you just ask whatever. But no one uses them. Why? Because the information is too vast. It doesn't have context. It doesn't have, this is the things you're interested in. It needs a better practical application, in my view, to make this actually more useful, like what I showed you here. But this is because it's inside the organization, right? Let's say you create this app, you have this IAP authentication based on different groups that you have in your company to get different access to different kind of information. And then you feed the information from the database that this is the information you have from your Confluence pages, Slack, all of this other stuff. And then I think this is very, very useful. The reason I feel this is very, very useful is because, the things I see at work, it's very difficult to supply information, especially from the platform team's perspective. You want the users to have the best onboarding process, the easiest way to find information, to create infrastructure, the blueprints and all of this stuff. But no one's going to be able to find all of this stuff on confidence, because it doesn't matter how well you structure it. I think it's just a lot of effort, right? You need to train people to see where things are. But if you actually can just go there and ask the question, what is this? Where is this stuff? And you can even provide links, right? So the thing is about when you provide this information, the document gets returned from the vector database. You can attach other things in there as well, right? You can add additional columns. You can actually reference the actual links from the conference page. If you have that as part of the information, then it can feed all this information back to the users. Then it become a lot more useful. The second use case where I see from the industries is getting more traction, which I think this pattern can be applied as well. You can even get away from it by using BigQuery Vector search, in my opinion, because this is for assist, right? This is for customer service, which means probably for your, let's say, agents, call center agents or customer service agents that they want to somehow get information about certain customers, but you don't want to really give that information direct to the customers because this sort of thing can go wrong, right? So because you need a lot of fine tuning to over time for, to give this to customers. You need to be careful of what you're serving in the portal, if that is customer facing, right? Because the chatbot can just go crazy and then started doing something that's very unpredictable in 0.1% of the time. That's still a catastrophic disaster. So this is just about assist, right? What this just means is the agent or the customer service representative can basically, if the customer asks a question, right? And you don't know how to answer it, you come to this thing and you say, look, I want to know this sort of stuff, like of this customer's transactions or this customer's issues has been raised. And it will give you this kind of information, such as the customer had a bad experience here and here, because you have that data behind the scenes, right? But this is not external facing, it's internal facing. So it's a lot safer. But the thing is, it can still tell you wrong information. This is why there's still some risk in here. Because what if it says something that's not true? Then you told the customers. Then it causes problems, right? So, but you can roll it out at least to get the agents to, to look at the feedback, to look at what it's actually saying, and use that experience to combine this experience to help your customer, or as a whole, with more data, right? This is another use case I can think of that's actually quite useful. The last one is for consumers, the chatbot for consumers. This is the red zone because, as you've probably seen, some of these things that blew up on the internet is you don't want to just have whatever information that you just chuck it out to the internet to the customers. Even the information you retrieve is just about those customers, because there's certain information combined in there. You don't know what the language model is going to say, right? Because this is approximate. If it goes wrong, it can tell the customer some information that they're not supposed to know, right? Or there's certain things it's only for the agent. You need to be very, very clear on how these things are structured. So this is where the risk is pretty high. And also you can't use BigQuery for this stuff, right? So the vector search for BigQuery is only designed for like more of analytical use cases. You can probably get away from if you have a small group of agents, but you can't really get away from have a consumer traffic. It's just going to kill your database. There's no way BigQuery can serve that concurrency. It's the wrong type of database. However, you have other databases such as Postgres, probably Elasticsearch as well, which I've not tried, but just kind of seeing it recently, that you can use these operational production services that for consumers, that if you want to serve things with a lot better performance and much lower latency, to directly to the customers. But this is very, very, red zone in my opinion right now. And then a lot of this effort has to be based on you have very good data structure categorized to do exactly what you want to do. I'll give you an example, right? Let's say where this is, in my view, you can test some of these scenarios out is the data that you use to feed into those models will be harmless information, such as if there's certain things you want to make a recommendation to the customers. If it goes wrong, or if the recommendation is not great, it doesn't matter, right? So it will be based on certain information that is harmless, right? But if you use information such as the customer's bill, and if those things go wrong, that could be really, really bad, right? Or you started talking about something else. Now, if you're not really thinking about what kind of information you feed back to your customers. So that's just something you want to be considerable. So in my view, the first one is actually you can do it now. It's not really much risk, right? The second one is, but it's still very useful, right? The knowledge-based thing. The second thing is you can do it now, but you kind of need to understand exactly, how do you train the agents to deal with those incorrect answers, what do they need to validate and check for those kind of things, right? Third ones, be very careful because this is where things can go horribly wrong. Okay, just a quick summary of what I talked about today. So specific for Langchain, I think it's surprisingly straightforward to make something usable with good enough quality, right? So I've not actually done a lot of research and then learning, probably a couple of days of learning. And it doesn't take a lot of, if you're already experienced engineer, you can easily plug something like this together. Although some of this stuff, you know, get stumbled into one or two things, but it is still very easy to get something working with good quality, such as, using the BigQuery Vector database to plug it in. And it's really easy to mix and swap things like LLMs and vector databases. As some of the examples I've given, you can easily swap between the OpenAI ones, the Google ones, on the LLM part, on the vector, on the embedding, getting the embeddings. And then because then if one works not as good as the others, right, then you can actually swap it out to use something else without changing much of your code. The other, positive point is the restriction, you know, because of the prompt is well templated, there's lots of examples of how you can do this. In my testing, like with all of the scenarios I've tried, it works most of the time. It rarely talks about anything that is outside of the context. So, but this is, again, some people will say they would jailbreak the LLM models to talk something else, right? But again, what can it really talk about? I mean, if it's out of the context, look, some of these, especially if you're using it from within the organization, there's not really that much can go wrong. But if you use it for the consumers directly to the customers, a lot of things can go wrong if you're not careful. So the negative points with Langchain, but I guess maybe there's a version 2 gets released and the version 1 is just more of like a prototype. But I really don't see is that easy to use in the sense of, let's say if something doesn't have it built in, you want to use your own one, such in this case, the example I gave on, using my own, retrievers, right? So, and, you know, it's, this documentation is just not there from what my limited research. I can't really seem to find a way to, how do I do this rather than looking to the source code. And I have to dig into the source code. Okay, what is the method I need to implement to actually extend it? You know, it's quite difficult to use. I would rather have something that's a bit more obvious. Let's say you can just use compositions instead of this inheritance to basically implement something that is clearly identified and then you put it in there, right? The Langchain code quality is not really the best from what I can see. You know, that bug I saw, that was, you know, it just works one way but not the other. But I didn't actually create any of these database structures. How come there's no testing involved to retrieve the data from the JSON data type and it just doesn't work? So maybe I missed something important, but from the code I can see it certainly is returning a dictionary when there's a JSON column. So I'm not entirely sure why that code doesn't even work. It's a built-in class that for a vector implementation of BigQuery. So, and also that piece of code is duplicated like twice, you know, almost the copy and paste in two different places. So I think the code quality, I think it really needs improving over time, but given it's a very new product, this whole thing only just got started 6 months ago, maybe. And that's really understandable, I think. But anyways, I think the positive side is actually, in my view, is very strong. And especially how easy it is for, you know, someone like me with a software engineering background without too much knowledge of this whole ML thing works. And how quickly I can put something together that is usable. I think this is quite amazing that I can build my knowledge on top of that to really kind of dig into the details and how exactly these things work, and over time to deliver value. Okay. So that's everything I've got for today. Yes, hope you found this useful and thank you very much and see you next time.
Go out!